Hello everybody, I hope you're all doing well. Root Beer here. We're sort of in the midway point through Part C of our 2018 Grade 8 Gauss paper. We're on question number 23. I usually find 21 and 22 to be somewhat easy, very similar in difficulty to things like 19 and 20. But 23 is where things can start to get a little more tricky. 24, okay. 25 is usually meant to be the hardest question on the contest, although, depending on what material is presented, you might find 24 or 23 harder, depending on what they're asking about. But what have we got for question 23 from 2018? The smallest positive integer n, for which n times n plus 1 times n plus 2 is a multiple of 5, is 3. Yeah, 3 times 4 times 5 is a multiple of 5. All positive integers n, for which n times n plus 1 times n plus 2 is a multiple of 5, are listed in increasing order. What is the 2018th integer in the list? Alright, so they certainly don't expect us to write out all 2018 numbers. That would be a massive waste of time. So, we gotta figure there's probably a pattern. So what I would do is, if I don't have an instinct about this, I do, but I'll suppress that for a moment. But if I didn't have an instinct about this, I would play around with some numbers. So they told me 3 works. I'll make the n a bit bigger. They told me 3 works. Why? Well, it's 3 times 4 times 5, and that is a multiple of 5. We could try something else. Now, we know nothing smaller is going to work, but we could try 4. And look at that. 4 times 5 times 6. That's a multiple of 5. Because 5's in there, and 5's a multiple of 5. What about 5? Sure, you're starting off with the 5. We don't really need the 6 and the 7. How about 6? Well, 6 times 7 times 8. Well, that's not a multiple of 5 at all. Why? Well, none of these numbers are multiples of 5. 5's a very nice number. It's prime. So there's no way you can multiply a bunch of numbers together, have it be a multiple of 5, and have none of the numbers be a multiple of 5 themselves. This is different than, say, 6. 1 times 2 times 3 is 6. So that's a multiple of 6, but none of these numbers were multiples of 6. But it doesn't work that way with primes, and 5 is a prime number. So, okay, armed with that knowledge, 7 doesn't work. 7 times 8 times 9, but 8 does. 8 times 9, that doesn't work, but then we do 10, and 10 is a multiple of 5. And then the next one will put a 10 here, and then a 10 here, and then we won't have a multiple of 5 again until a 15 appears here. And a 15, and a 15, and that'll keep going. So which numbers have this happen? Well, if we've got 15 here, what's the n that we're working with? Well, we'd have 15, 14, 13. So 13 would work. And how are we finding these numbers? Well, if we highlight the multiples of 5, the number that we start with, 3, is 2 before a 5. And then 4 is 1 before 5, and then of course 5 is a multiple of 5. And then the 6, that doesn't really work out, neither does the 7. But 8 is 2 before a multiple of 5. And then the next one, 9, is 1 before a multiple of 5. So, if you're relatively quick with patterns, you might say, well, 5n minus 2 will do. Well, let's not use n. Let's not use n because they've got an n in the problem. Let's say k. 5k minus 2, 5k minus 1, and 5k are what the numbers are going to look like. So n equals one of these for some k. That's always how it's going to look like. Either it's going to be 2 before a multiple of 5, 1 before a multiple of 5, or a multiple of 5 itself, and the rest just won't do. Okay, so I guess we go 3, 4, 5, and then 8, 9, 10, and then, what would it be, 13, 14, 15, and then 18, 19, 20, and 23, 24, 25. I'm noticing something's going on with the units digits as well. So that's kind of interesting. Now, how are we getting these numbers? Well, these first 3 come from 5 times 1. Either they're 2 before, 1 before, or exactly equal to 5 times 1. The next 3 all come from 5 times 2, and the next 3 come from 5 times 3. And the next 3 come from 5 times 4 and 5 times 5. So if I wanted the 2018th, looks like they go in groups of 3. And how these groups of 3 grow is based off the multiple of 5. I'll show you another way. So if we look at the first one is a 3, then a 2, and the second one is a 4, the third digit is a 5, or the third n is a 5. The fourth one is the 8, the fifth one is the 9, the sixth one is a 10. So, oops, 13 goes down here. So the third number in the sequence is just a multiple of 5. Not only that, the sort of, let's say, 3kth term in the list is 5k. We can use that to try and figure out where we are with if we just extended this pattern down to 2018. Now, 2018, not a multiple of 3. What's the next multiple of 3? Okay, and so we could divide 2018 by 3, and we see it's 672.666, so the next multiple of 3 should be 2019. So 2016 is that's the 2016th digit is, or not digit, n is something. Then the 2017th is something. The 2018th n is what we want. That's the prize. And then there's the 2019th. But these 3 are going to be part of a group of 3 in a row, just like these 3 were. Not only that, 2019, this is the 673rd block of 3. So that's going to be our case. So what goes for 2019? Well, it's going to be 673 times 5. That's 3,365. And what goes in the spot before it? 1 less. What goes before that? 1 less. And then the previous multiple of 5 goes there. And we could work backwards as well. But we just care about the 3364 that is the 2018th in our list. And 3364 is right there at the end. That's all we're going to need. So we bubble in E. We've got 2 more questions left to go on the contest, so I will see you for question 24 in the next video.